Good evening. As I was about to shift gears from layer 3 stuff into layer 2 stuff, which is covered from chapter 4. From chapter 4, that's where we look at switched networks, which is all about switches, switch configurations, so that we see how we create VLANs and all that. So as I was about to do that, and also you know that in CCNA1, layer 2 stuff is introduced from chapter 5, which we never looked at, but anyway, like I said, CCNA or CCNA 3, 2, 3 and 4, you know, they build on CCNA1. CCNA1 just lays the foundation. So when we look at chapter 4, it will have covered all that stuff. So as I was about to do that, I realized that there was a few concepts that about Eigrp that we did not look at, and that is how we advertise a default route and how we do summarization, yeah, to make routing a bit efficient. So as you can see in my topology here from the previous lesson, you can see that this company have experienced some growth in that you can see the HQ now have some more networks. Now this here could be, if I can grab my pen, this here could be maybe stuff around here. So these networks here could be VLANs. Yeah, this could be VLANs behind the HQ router here, or they could be other branches that are not shown. Yeah, like I've said, this company, my horrible drawing of one links that's what I'm trying to represent here. So the bottom line is the HQ, the edge router, somehow knows about all these networks. Now it is a bit inefficient to advertise all of them to the remote side, because you know that usually organizations will have maybe their core router, the core or the router at the edge is maybe the beefy high-end device. Yeah, maybe it's the biggest device that have the CPU and memory requirements to handle bigger routing table. These could be, you know, small routers like the ones you have at a Soho environment. So anyway, you need that skill to make your, because here's the scoop: a bigger routing table will make your can be a source of bottleneck of your traffic. So anyway, enough with the talk. Let me just demonstrate, you see what I'm trying to get at. To simulate those networks, all I have done is where is my console? I've gone to the HQ router. Using loopback interfaces, I was able to create those networks. Yeah, so you can see that just using the loopback interfaces, the HQ router, if you type show IP route, show IP route, if I can type, you can see that the routing table is really big, yeah, relatively big compared to the other routers. And I have since advertised these networks into the have I really do show run? Don't need to do show run section router. Yeah, you can see that I have advertised all those networks. So if I go to router 2, type show IP route, show IP route, you can see that my subnets are not appearing. Yeah, Now, this is the devastating effect of if you have not done no auto summary, because you see now the HQ router which knows about these networks, which I'm saying that you can imagine them as VLANs or branches to other branches that are not shown here, but either way those routes are in the routing table of this of the HQ router. So now with auto summarization, what the HQ router is doing when it is sending those advertisements is telling the neighbors that, hey everybody, I know about 172.16.0.0/16. yeah, that can be devastating, because let's say that you had that network of 172.16.0. So you had let me write so that .16.0.0/16. yeah, you did your subnetting. That's how you came up with these subnets, which you have used to these mysterious subnets, other buildings, you know, maybe to humanity and all. So all those are routes. So you have subnetted, and you have used just 8 subnets of those. Had to pause a bit. I was disrupted a bit by my son. Where was I? So we are saying that after you subnet these networks, you don't want the HQ router or router 1 to advertise to the rest of the world that it knows 172, as in this whole subnet, because you see, after maybe you came up with your addressing scheme, you have other subnets, because you can see that 172.16.0.0/16 is a huge, you know, this thing you can subnet it to a lot of subnets. yeah, so maybe in future you'll come and then you have other branches being connected to these other guys, or you have VLANs here that you use some other subnets. yeah, maybe like you use 172.16.150.0/24 somewhere else in your network. yeah, if you do that, or if you let, or right now this Eigrp, a modern sophisticated routing protocol, is behaving like the good old RIP version 1 or Eigrp, the legacy protocols. yeah, you don't want and this is where now you can start having intermittent connectivity, because like for instance, let's say that now if you leave that auto summary on router 3, let's say that this 172.16 is somehow known as a VLAN connected in this LAN. yeah, now this router advertises that it knows 172.16.0.0. so you see, first of all, it will not learn about these subnets, and it might actually ignore this update from router 1, because it believes that it is also connected to this subnet. So a user here that is trying to communicate to this, a user here that is trying to communicate, say, to a server that is connected on the HQ router here, it might send some packets this way and others this way, and assuming this link is not there, and I know now I'm just scribbling all over. So I think this is the scenario that I had tried to explain, where router 3 will believe that router 2 and router 1 somehow, let's say this LAN is somehow merged, yeah, because he's hearing about 172.16.0.0/16 from both router 2 and router 1. So anyway, I think I've gone through a lot of trouble trying to explain that, but anyway, you don't want to leave auto summarization on. Instead, you want to do summarization yourself. and so that you can make sure that you have as in you have an efficient summary route. Yeah, and this is where now we'll come to appreciate this third reason why you might want to choose you might want to use Eigrp, because of the flexibility in summarization. Because with Eigrp and also RIP version 2, by the way, the summarization I'll show you here applies also with the RIP version 2, is you can go to any interface and apply a summary route. Unlike OSPF, when you look at OSPF, you'll see that OSPF, you have specific areas that you can do summarization. Yeah? And this summarization is all in a bid to make your routing efficient, so that you don't have slowness, because one of the dreaded network admins call is where your users are complaining that the internet or the network is slow. Yeah, you'd rather troubleshoot something, or many network admins would rather troubleshoot a network that is down. There is no internet, as in you just start from scratch like that. Rather than if your users start complaining that your network or whatever service they're trying to access is slow, you have anything can go, as in there's a lot of stuff that can go wrong to cause slowness in your network. Maybe there is a computer of some user somewhere that was infected by some Trojan horse that is producing all kind of traffic in that LAN and bogging down everybody. It could be the server, the email server they're trying to access, that is corrupted by some virus. So you see, you have a lot of stuff that you never know what could be causing the slowness in your network. So when you're setting up your network, of course, it's always good to make sure that you have that stuff. And as I was explaining, I lost myself. Anyway, I was bringing you to this slide to, I think you have seen me demonstrate how we do summarization. So essentially, you just convert those IP addresses into binary, and that's what I've done here. So 172 in binary is this here. So what we want to do, and in fact, it was not necessary for me to convert the first 2 octets. Yeah, 172.16, we can see that is consistent throughout the subnets. We can obviously see the changes happening at here. So we can see that the change is happening here, and specifically, if I can draw my straight line, is somewhere here, there, right? Now when you do that, let me pick my pen. When you do that, we know that we have 8 let me try to increase the size of that so that we can see what I'm writing. So we know that we have 8 bits here that are the same or similar. We have 8 here that are the same, and then we have 1, 2, 3, 4, 5 bits that are the same, yeah, throughout this whole whatever. What is it? Okay, so once you do that, you copy everything to the left of this line. You count the bits, yeah. So in this case, we can see that it's a slash. 16 plus 5, that is 20, isn't it? 21, if I can do the maths. Yeah, it's 21 if I'm right. Now everything to the right of this line becomes 0. Yeah, everything to the right of the divide here, you convert it to 0, and then you convert everything back to decimal. So if you are to convert all these guys to 0, so essentially you can see that you'll have what you have here, right? So we'll have, now if you convert this thing back to to decimal, you'll see that you'll have 172.16, because this still remains as 172. This is still 16, but this whole here will now be 0. This will be 0, and for all, because everything now here will all be zeros, yeah, because that's the rule, dot 0 dot 0. So if we configure, this would be a summary route that will harmoniously advertise all these networks as one block of advertisement. Now this is more efficient because router 1, or the HQ router here, if I can get back to it, where is it? So my HQ router here is not claiming to own the whole 172.16.0.0/16. yeah, so in fact let's go do that configuration. So first of all, we need to do no auto summary. So we go to router Eigrp 1, we do no auto summary. So right now, and it resyncs the neighbors, essentially brings the neighbors down and then reforms them again, and it's a graceful restart. You can see those status messages, and here you can see is a dual the algorithm. Yeah, now if I do show IP route, right now my router is a bit inefficient because the routing table is big, but at least we are getting the specific subnets that we were not getting up here. When I did show IP route here, we were getting one big block of a slash whatever. So now to configure that summary route that we have determined here, with Eigrp you go to specific interfaces. So in this case, we need to configure it on interface 000 and interface 001, because we want that summary route to take effect as it goes to the other routers. And just for glance, we can check whether my router 3 is getting the same. Yeah, you can see is a big routing table relatively speaking, of course in a lab, or figuratively speaking in a lab environment. But in the real world, I've said that this thing can save you, can improve a bit on the efficiency of just like the recursive lookup that I talked about. Yeah, if you have a big routing table that you have not implemented static routing, you have a lot of static routes, and you're doing a lot of recursive lookup, that also is something that will cost some CPU, whatever of your, will cost some resources. Yeah, it will cost you some resources on your device. And so anyway, here we are we're trying to look at how you can make things a bit efficient. So we do IP, so you go to specific interfaces. Yeah, you do IP summary. Is this the syntax? I think yeah, IP summary address, and you need to do, yeah, so this is what I was saying, that Eigrp and also RIP version 2, you do pretty much the same. So you do Eigrp, and you have to put the autonomous system number, and now you put the summary route. The summary route we have determined is 172.16.0.0 255.255. What is a /21 in main? How many are those? That is 5. I think it is 248, yeah, if I'm not wrong. 248.0. So that's a /20. Is a /21. /20, 16 minus 21 minus 16 is what? Is 5, yeah? Yeah, I think it's 248, if I'm not wrong. All right, here you can tweak the administrative distance and all that. We're not going to go there, so you just do that, hit enter. It will resync the neighbors, no biggie. But of course, if this is a high, you know, some of those networks that a small outage of a few seconds can, or a glitch in the system can cause some issues. Maybe this is something you want to do in the outage window. And also for any eventualities, you know, that when you're making changes on your network. But anyway, IP summary. So I've gone to the other interface. I've just hit the up arrow, and so I've configured it on both the interfaces now. If I can get the topology on both 000 and 001. Now to see the effect of that, we go to show IP routes. Much cleaner now. Yeah, so you can see that it's now showing up as a /21 and all that. So we have minimized the size of the routing table. That way, you know that whenever these routers are forwarding packets, they have to always consult the routing table, and that's why we want to make that routing table lookup as efficient as possible. Yeah, so that's how you configure summary, or that's how you do summarization and configure the same on your routers with Eigrp. Now if you come back to the router where you did the summarization, on this one is not affected because you know that those networks are directly connected to it. So, and you can see that there's a summary route that goes to null 0. Null 0 is like a black hole. Yeah, any packet that is sent to null 0 is and this is a loop is a routing loop prevention mechanism. Yeah, because when you configure that summary route, let's say that the HQ router somehow loses connection to one of these VLANs or whichever on these networks. Yeah, let's say 172.16.1.0 goes down. Now when router 1 sends a query trying to ask these guys, hey, does anybody know of a backup to 172.16.1.0? It is down on my side. These guys will just respond no. So as in they won't propagate the query, because if you have not implemented summarization, that query packet have to be sent around. And you see here we're just showing some 3 routers, but like I've said, maybe this is a big network that have several routers. Now that query packet might have to go around the network for quite some time, and that's where now when you type show IP topology, you'll see stuck inactive because that guy is actively. So in fact now that's what we call bounded updates. You're bounding the updates, and if you don't do that, you might have a situation where, as you'll see in CCNP, the query packet, and I think another one, they can mess you up. Yeah, if you don't implement summarization nicely, because that's where now you might find routes stuck inactive. And so anyway, I think I'm digressing. So that's how you do that. So the next thing that we need to configure is how we advertise a default route. For Eigrp is slightly different when compared to the other routing protocols. Now first of all, of course, we can see the gateway of the last resort is not set. So my core router, I don't expect it to go beyond 168.0.1. I don't expect it to go beyond my, can we reach it? Do I even have I don't expect it to go beyond my router here at home in the cloud. I think I've not even, okay, from the last time I think I did not save the configurations that we had. Yep, so we can see that I've actually configured public IP address. Let's just assign it an IP address that's not in use in my home network here. So we do int f01. We can do IP add. It will just overwrite. You can type no IP address to remove this one, but you can just overwrite that one, 192.168.0.254. I don't think there is anything using that. .0. We don't need to do no shut because you can see that it's already at a no shut. Now let's try to ping that my gateway again. Yes, we can reach it. And the first ping is usually lost because we are doing ARPing. Now if I type show IP ARP, if I had not so anyway, we are populating those ARP, so the first ping packet was lost, but the consecutive ones, you can see that they are successful. So this guy can reach my home router, but we know that it can't reach internet because we need a default route. So we say IP route all zeros 0000, and so this is where, to avoid that recursive lookup, I was saying you can type the exit interface and then you type the next hop IP address, and the next hop IP address of course is my home router, or the quote-unquote ISP is our ISP here. So we hit enter. If you type do show IP route, now I said you can, or you're supposed to type the exit interface and also the next hop IP address whenever necessary, whenever possible, because that will avoid recursive lookup. Yeah, if I did not put the exit interface, I just put the next hop IP address, you would see it different. And I think I explained about recursive lookup. So right now we expect my whatever here to be reaching internet, and yep, we can reach it. So of course we cannot ping by URL because I've not configured a DNS server. I think we lost all those configurations from the previous lessons. All right, so my core router can reach internet, so we don't want to go here and repeat on all the routers. We want to use the routing protocol to propagate that default route. Now with Eigrp there are two ways. I'm saying it's slightly different from other routing protocols because you see I cannot do default, you see, or we can because we're doing default information. Okay, there is default information. Yeah, you can see that it doesn't have, the command is default information originate, so you can see that command is not even supported here. Yeah, so with the Eigrp you do redistribute static, but redistribution is a huge topic in CCNP, and is a necessary evil that you don't want. You see, it's an evil that you don't want to be running on your network, not unless you have a good reason to, or is something that you want to avoid as much as possible. So the problem with this, if you say redistribute static, you see my core router here could be having other static routes to some other sensitive departments. Maybe the accounts department, you have a static route that is only known to this guy. You have an R&D department, some sensitive areas that you don't want to broadcast to the rest of the network. So when you do redistribute static, it will actually work, because if you go to the other whatever and you type now show IP route, I can just hit the up arrow, show IP route. You can see the gateway of the last resort is set and pointing to the next hop. See, the good thing of propagating a default route, router 2 is actually pointing to .65. If you have another router downstream, it will, you know, auto adjust that the next hop IP address. Yeah, and so it was learned via Eigrp. That's why it's a D. The asterisk here, or the star, is what is telling us is candidate default, and it's all zeros. This is external Eigrp routes have an administrative distance of 170. Now this is something that comes to haunt you when you do redistribution, because you see Cisco here is trying to you can see the believability of a redistributed route is horrible. Yeah, it's not as believable as internally learned, because like I've said, redistribution is something that you want you want to avoid as much as possible. So I was saying, now the problem with this is every static router that was on the HQ router will now be broadcasted to the rest of the world. So, but anyway, for the exam, maybe you want to learn that, though in reality or in the real world, people don't like using that because of that reason. So what you can do is you create a network using, say, a loopback interface. But in this case, we can use this quote unquote public IP, though you should not advertise a public IP into your routing protocol, because the moment you type network this, you'll start sending hello packets to your ISP, which of course is a security risk and all that. But we have seen that you can also configure this interface as passive. Maybe let me just demonstrate, you see what I'm trying to say. So but before you actually advertise that network, you can type default, or you first type default network. It's not default network, it's IP default network. Yeah, IP default network. Here we can say 192.168.0.0, and it's a /24. Yeah, so I'm choosing to advertise this one, but I'm saying that in a properly designed high security network environment, you probably don't want to put that one as the default network. Yeah, the network between you and the ISP, because we'll then, after now, the next step, we'll advertise that network to the you probably don't want to do that. You can just create another network, a private IP, using a loopback. Yeah, like maybe one of the subnetted one of your subnets that you did subnet, maybe like a /30 somewhere that you have not used in your network. You create a loopback and then you designate that one as the IP default network here. But we can just do that. Now you go back to the routing process, router Eigrp1, then you say I'm forgetting the command. Yeah, you actually advertise the network. Network 172.16. I'm jumping all over such that, and probably you want to put the wildcard mask so that you specifically advertise that that network. Now before I hit enter, first need to come back here and see whether our default route is still, whether you know that we removed the static route. Yeah, in the redistribute whatever. So we can see that the gateway of the last resort is not there and our default route is gone. So I hit enter on the HQ, that is on router 1. I'm back to router 1. Now I come back to router 2. So this thing is weird. You can see that my network shows up, and this is what I was saying, that you need not to use your public IP because it will show up in your whatever. But there's no harm per se, even if it is advertised. But you know that normally you should not advertise your external IPs because that public IP is external, it's not internal to your network. But of course, if you have configured passive interface, you know, this is where we need to do passive interface F01, because without doing that, right now, if you do a Wireshark capture, you'll see some hello packets going to the ISP. You don't want that. Yeah. So we can make that on passive, but the bottom line is we have the default route. Show IP route. Now it's a bit counterintuitive because you see here, you can see that the gateway of the last resort is set, yeah, but you expect when you come to the routing table to see all zeros, right? But it shows something like this, and it works, as in if you go to these devices, to your PCs now, they can be able to reach internet. But of course, in our case, they won't be able to, because I have since removed NAT on my core router. I did not save those configurations. So anyway, those were the two concepts that I think we had not covered in the previous video of the Eigrp, that I think is in your notes. So with that, I think now we can logically transition to matters layer 2. So in the next video, we'll just pick up right from there. So, but with that, I hope this has been informative to you. I'd like to thank you for viewing.